Okay, here we have the function f of x equals e power 3x minus e power x, and we determine the intervals where the function is increasing. So to determine the intervals where the function is increasing, we prepare the sign chart for f prime of x, that is for the derivative of f of x. And from this sign chart, we determine if in any interval, if f prime of x is positive, we see that in that interval the function is increasing, and if in any interval if f prime of x is less than 0, that is if it is negative, we see that f of x is decreasing in that interval. So let's see how to determine that. We are going to first find the derivative of f of x. So let me copy the f of x. This equals e power 3x minus e power x, and we differentiate to both sides with respect to x. The derivative of e power 3x is e power 3x, and then using the chain rule we also find the derivative of 3x, which is 3. So we multiply this 3 with this one, minus the derivative of e power x is e power x. So this equals 3 e power 3x minus e power x. So this one is f prime of x, which is the derivative of f of x. Now we should find the critical point of this function. For that, we set up this equation, that is f prime of x equals to 0, and solve for x. So let's replace f prime of x equal to 0, and this gives 0 equals 3 e power 3x minus e power x. I'm going to factor e power x from the right side expression. That is, I factor e power x. So, which means the first term 3 e power 3x, we divide by e power x. And so this equals 3 times of, we subtract the powers according to the law of exponents. So this will be 3 e power 3x minus this is x is 2x. So when you factor e power x, the first term will be 3 e power 2x minus e power x divided by e power x is 1. And so we have written this in factor form. And this means we can now see that e power x equals 0, or the other factor, which is 3 e power 2x minus 1, this equals 0. This one does not have solution because this is always increasing, and it will never become 0 for any values of x. So here we see no solution. And let's consider this equation, that is 3 e power 2x minus 1 equals 0. We first add 1 to both sides, so we get 3 e power 2x, and this equals 1. Now we divide both sides by 3, so we get e power 2x, and this equals 1 by 3. To solve for x, we apply natural logarithm, that is natural logarithm of e raised to the power of 2x. This equals natural logarithm of 1/3. Now using the power rule of natural logarithm, we can bring this power in front. So therefore this becomes 2x times natural logarithm of e. This equals natural logarithm of 1/3. We know that the natural logarithm of e equals 1. So replacing this quantity by 1, we get 2x times 1 is 2x, and this equals natural logarithm of 1/3. We then divide both sides by 2 so that we solve for x. So therefore we see that x equals natural logarithm of 1/3, this divided by 2. And so this basically is the critical point of the function, that is x equals natural logarithm of 1/3 divided by 2. We can also give it a decimal approximation by plugging this expression into the calculator. And when we do that, we get x approximately negative 0.549306. This one is approximated to 6 decimal places. And we are going to use this critical point to prepare the sign chart. So let's put this on the number line. We create a number line. Then put x, this one is negative 0.549306. We are preparing the sign chart for f prime of x. So let's consider the f prime of x. We can consider this expression, which is in factor form, that is e power x times 3 e power 2x minus 1. So I'm going to consider this as the f prime of x, which is e power x times 3 e power 2x minus 1. So here we have two intervals, that is from negative infinity to this critical point, negative 0.549306. That is one interval, that is negative infinity to negative of 0.549306. This one is to the left of this critical point, and then the other interval is from starting from this one, negative 0.549306 to positive infinity. So let's consider some random points to the left and to the right of this critical point. First, I'm going to consider a random point to the right of this critical point. That is, I can consider x equal to 0 and plug it into this first derivative. So it is f prime of 0, and this equals e power 0 times 3 e power 2 times of 0 minus 1. And so this gives e power 0 is 1 times 3 times this one is 0. So once again, e power 0 is 1 minus 1. This gives 3 times 1 is 3. 3 minus 1 is 2. And 2 times 1 is 2. So basically, we need to understand the sign. So this one is positive. So therefore, we mark positive on this interval. Now let's consider some random points to the left of this critical point. So I'm going to consider negative 1 and find f prime of negative 1. This equals e raised to the power of negative 1 times 3e times of 2 times of negative 1 minus 1. And so this equals, I can write this e power minus 1 as 1 by e times this one is e power negative 2, which equals 1 by e squared. And so here we have 3 times of 1 by e squared, which is 3 by e squared. We then have negative 1. So let's simplify this. We get 1 by e. This equals 3 minus e squared divided by e squared. When you simplify this fraction inside the brackets, and so this basically equals, in the numerator we have 3 minus e squared divided by the denominator e cube. We can find its decimal value by plugging this into the calculator, and when we do that, we get negative 0.2185. And this one is basically a negative number. We just need to understand the sign. So to the left of this critical point, we understood that it is negative, and therefore we see that the f prime of x is positive only in this interval, which means the function f of x is increasing in this interval. So we see that the function f of x is increasing in the interval from negative 0.549 306 to infinity, or we can also write down in terms of exact number. This one is basically natural logarithm of 1/3 over 2, or otherwise we can write down this as negative of natural logarithm of 3 over 2 to infinity.